this is your instructor Fishini Sadat. We are coming to look at addition and subtraction of vectors. And in our previous lesson, we had already looked at how to represent vectors in various forms, including the components form, the distance bearing form, and the Cartesian form. We also look at how to represent vectors graphically. I hope they are all still fresh in your minds. So this morning we are going to look at how to add and subtract vectors. How to add and subtract vectors. But before we do that, let's consider the learning objectives. By the end of the lesson, students should be able to 1. Add and subtract vectors geometrically. 2. Add and subtract vectors algebraically. Good. So we are going to begin with our first objective. So for instance, when we are given two vectors, we can be asked to add and subtract the two vectors. That is, add vector A to vector B, or subtract vector B from A, or vector A from B. So let's begin with the addition. How do we add two vectors? First, geometrically. So to add two vectors geometrically, you first have to represent the first vector on the graph using the graph. So let's represent the first vector, vector A. So vector A has coordinates 2, 3. It means that the 2 is the movement along the x-axis, that's the x component, and then the 3 is the movement along the y-axis. So we start from the origin, that is 0, and then we count 2 units along the positive x-axis. 1, 2. Then we now count upwards 3 units. 1, 2, 3. It means this will be the final point of our vector. Then we join that point to where we started, that is the origin. After joining, you have to show the arrow. You have to put the arrow to show the movement of the vector. So this is for vector A. Now, the next vector is vector B, the one we are to add to vector A. To add two vectors geometrically, you have to place the vectors tail to head. You have to place the vectors tail to head. So because we are going to add, we are not going to draw the vector B separately, but we are going to place it tail to head to vector A. So we begin from where A ends. Then we now draw vector B. So vector B, it has x coordinate 6. It means that from this point we move 6 units along the x-axis, the positive x-axis. So 1, 2, 3, 4, 5, 6. And then we now move 2 units upwards. 1, 2. And this is where it ends. So we join that point to the head of vector A. Okay. So after joining, you have to show the arrow to show the movement. So you put the arrow to show the movement. So this one represents vector B. This represents vector B. So what then do we do? We now join the end point of vector B to the starting of vector A. To the starting of vector A. Okay. So here the arrow also shows towards this direction. That is from O up to the end of B. So the vector that we have drawn, we say, is the sum of vector A and vector B. So this vector is vector A plus vector B. And we can also say that is the resultant of vector A and vector B. So this is how we add two vectors geometrically. Now, we can write down, or we can look at the graph and then write the representation or the components of the resultant vector, vector A plus vector B, which we already know how to do. So to get the components for vector AB, we start from where it starts, that's here, the origin. Then we count along the positive x-axis. 1, 2, 3, 4, 5, 6, 7, 8. Let's do that again. We have 1, 2, 3, 4, 5, 6, 7, 8. So we can see that the end point coincides with 8 along the x-axis. It means that the x component is 8. Then the end point, you trace it to the y-axis. You realize that it coincides with 5. So therefore, we can say that from the graph, vector A plus vector B is equal to the x, we got 8, and then the y, we got 5. So this is how we can add two vectors geometrically using the graph. So our next will be how to subtract two vectors geometrically. How do we subtract two vectors geometrically? So let me clean this one, and then we look at the subtraction. Okay, so let's label the axis 0, 1, 2, correct. So this is the x-axis. Then here we have 1, 2, 3, 4, 5, 6. Then at the left side of 0 we have -1, -2, negative 3, negative 4, negative 5. So the same way to subtract vector D from A. So let's subtract vector D from A. So vector A minus vector D. We are going to do this geometrically. So first of all, you need to draw vector A on the graph. So let's draw vector A. We have done that already. So vector A is 2, 3. So we start from 0, 1, 2. Then 3 units upwards. 1, 2, 3. Then you now join that point to the origin. So you show your arrow. So this is vector A. Then here we are doing subtraction. How do we do the interpretation? We are going to add the opposite of vector D. That is what we do because of the subtraction or the minus. So we are going to add the opposite of the vector D to vector A. So as you already know, to draw the opposite of vector D, it means that you start from where A ends, then you now move in the opposite direction. You also what we did for the addition. So for minus D, you start from the point where A ends. Because it is minus, you are going to move in the opposite direction. So the x component is 6. So from this point, we move 6 units in the opposite direction. So 1, 2, 3, 4, 5, 6. Then we now move 2 units downwards because the previous one was upwards. So because of the minus, we are now going to move downwards 2 units. So 1, 2. So this is where it ends. Then we now join this point to the end of vector A. Good. Then we show our arrow. This is the movement, the direction. We show the arrow. So this vector represents minus B. That is minus vector B. So now, what will be the resultant? That is A minus B. It's going to be the vector that closes the triangular shape. So you draw a vector or a line from the origin, the beginning of A, up to where the vector B ends. Good. So here too, the arrow moves this way. That's the direction. And this one will now represent vector A minus vector B. So this is how we subtract a vector from another geometrically. So this is how we subtract one vector from another geometrically. You first of all draw the first vector, and then you draw the second vector the same way from tail to head. But then you have to be conscious of the sign. So the second vector, you draw it moving in the opposite direction. Then after that, you now close the shape, and that becomes the resultant vector. That becomes the resultant vector. Thank you very much.